So very warm welcome to everybody joining us on our spooky webinar today, where we are going to be discussing Wi-Fi security and some of the things that we need to think about and watch out for when it comes to 6 gigahertz. So who have we got on here today? Well, you have got myself and Mac. We are the directors of product marketing and ECSE here at Ekahau, and we have got Wireless Stu, or the Force Stu, however you want to refer to him. He is going to be assisting us today with our Q&A and keeping everything going in the chat. So why don't we get started?
Let's get started. So we are going to talk about security today, but before we start talking about security, let's quickly discuss what happens before we even reach that stage. So first of all, if you have a Wi-Fi client, the client needs to discover the access points, the radios it can associate with, right? So first we need to do a discovery to see what BSSs are available. BSS, it stands for basic service set. So that's a radio inside an access point and the stations associated to it. Once we have discovered our station, well, our access point radio or radios, we can then start making a decision. So our client will think through, what options do we have available to me? How many radios do I see? Which radios do I like the most? Which is the most attractive from my perspective? And then this decision-making process is called the green diamond algorithm that the client is running on its end. It's always down to the client to decide which AP, which radio, which BSS ID. So BSS ID, it's a MAC address of a radio the client will join to. So after client has made a decision about the joining the specific radio, it will then possibly go through authentication and association process using a security method that is configured for a specific SSID. I say possibly because with open, for example, after open system authentication and association, there is nothing else later, as we are going to see in a second. So let's focus on one thing at a time, starting with the discovery. So guys, 6 gigahertz discovery is a little bit of a big fan to be in because it's a little bit different to what we have had in 2.4 and 5 gigahertz bands. Just as a quick refresher, we had beacons and probe requests and probe responses available to us when it comes to discovery in these two older but still alive bands. So the client could either wait for a beacon to discover what's happening on the channel it's listening to, or if it wanted to have the answer faster, it could send a probe request asking, hello, anyone out there? And then all the radios on the channel that hear the question will respond to that with a probe response saying, hello, I'm radio on channel 36. I can do this and that and blah, blah, blah. So everything was easy because everything was in band. So if a client wants to discover a radio on 5 gigahertz band, it will be scanning 5 gigahertz band. Easy peasy, lemon squeezy, because we have around 25 channels on 5 gigahertz band and around 13 channels on 2.4. But on 6 gigahertz, my friends, it's an entirely different story because at least in the US, we have up to 59 channels. And that's a massive, massive amount of spectrum to scan, to go off channel, to find next radio to jump to associate with, or to roam to reassociate with. So it can take time. If your client, for example, is on a voice call and you move down the corridor and you are on channel 5, then you will have to scan potentially even like more than 50 channels to find your better alternative in the old world of Wi-Fi BSS discovery. So we have to introduce some new methods on 6 gigahertz to make it a little bit faster. So first method that I wanted to talk to you about is called the RNR, which is the reduced neighbor report. And this is the out-of-band method. First time we are using out-of-band methods for real. We could have used them in the past, but we didn't. And now we are about to start. So it means that my 6 gigahertz capable client will look for 2.4 or 5 gigahertz radios, scan them, find an access point with a 6 gigahertz radio collocated inside the same AP to find out about that radio out of band. So I can scan 2.4 channel 1. If I have an access point that has 2.4 gigahertz radio on channel 1, it will respond to me saying that, hi, I'm an access point with a radio on channel 1 on 2.4, with a radio on channel 36 on 5, and with a radio on channel 5 in 6 GHz space. So the client will not have to scan entire 6 gigs, it will just go to channel 5 because it knows that the radio exists on that channel. So that was out of band, a new thing. And then we have 2 in-band methods. I say 2, you can see 4 on the screen, but the 2 marked in red, they are not really going to be used too extensively, we think. And I say we think because this is, most of it is a theory now. In practical world, most of the real 6 GHz stuff that we have seen, it uses something called the PSC, a preferred scanning channel. So PSC, it will be used mostly in the US, because in the US, you guys have 59 6 GHz channels. That's a lot of channels, and you can use wider channels like 40 or 80 megahertz. And since PSC is scanning every 4th channel, that means that it will discover 80 megahertz channels flawlessly, and you have just 15 of those 80 megahertz channels to scan through. So it's not going to be massively time consuming. So PSC will be wildly important and popular in States, not necessarily in Europe and outside of States where we have around 25 channels available to us. We probably won't be able to stick to 80 megahertz, so we will have to be relying on the RNR to discover our 6 gigahertz radios. Okay, and I think it's enough when it comes to 6 gigahertz discovery. Let's move on to what happens next after our station discovers all the radios it can connect to.
Okay, so we're going to discuss what we sometimes refer to in the industry as what we call a green diamond. And what we are going to talk about here is basically what happens when you take your device into an environment where it's got lots of different access points advertising the same SSID. It comes down to the decision of which one we want to choose from. But before we talk about it from the phone's perspective, let's just talk about it from the human perspective. And if you are feeling slightly hungry and you want to get some food delivered to you, perhaps you want to get a nice pizza delivered to your home where you are, you take out your mobile device, you go onto this food delivery application, and then you will type in the word pizza. When you type in the word pizza, you get a whole list of different restaurants that can deliver you some pizzas. And then you have to make a decision. Am I going to choose the restaurant that can deliver me pizza the fastest? Am I going to choose the restaurant that has got the highest rating for the feedback from the customers? Am I going to choose one that's got the highest food quality rating, the hygiene? Do I make a decision based on price? I have to think about all of these decisions. And if I'm ordering a pizza, I may have some different requirements to how Mac may want to order a pizza, or even Stu. So we all have our own internal algorithm that we go through to decide what restaurant we want to order pizza through. So why are we talking about this and making everybody hungry on the webinar today? It's because I want everyone to remember that we all have our own decisions that we make when we want to decide where we want to get pizza from. Because I want to then translate that to the green diamond algorithm process for our client devices when they go into an environment where they can hear an SSID from multiple access points being broadcasted. So in this example here, we have got our mobile device, we have gone into the environment, and there are 4 access points. Access point A, B, C, and D. All of these access points are broadcasting the Ekahau guest SSID that I want to associate to. My phone hears that Ekahau guest SSID being broadcasted from all of the access points, and then the device has to make a decision, what access point am I going to associate to? And well, a bit like how we have our own internal algorithm for ordering pizza, all of our client devices have their own internal algorithm for why they would prefer to associate to one access point over another. And this green diamond algorithm can be something as super simple as just access point B has got the strongest signal strength that I heard from all of the access points. So I'm just going to go with you, Mr. Access Point B, and I'm going to associate to you because you have got the strongest signal strength. But what if we have got some devices that have got a more complex internal algorithm? maybe they don't just look at the signal strength coming from an access point. Maybe they take the signal strength into consideration, as well as the amount of stations connected to that access point, the channel utilization. What frequency is this access point using? Because yes, access point B, it may have a stronger signal strength than access point C or D, but actually there's 30, 40, 50 different stations all associated to that same radio, as on access point B, when I compare it to access point C that maybe has 5 or 10 stations connected. So even though access point B has got a stronger signal strength, I may have less of an opportunity to actually associate and then transmit my data to access point B. So I may choose to go for access point C or D. And all of our devices are different. And another thing to take into consideration is that your device may change its algorithm with a software update. So we have seen software updates get pushed down to devices, and the algorithm that they were using before to favor an access point over another access point, it can change. So depending on what these devices are, they can be really, really simple, or it can be really, really complex. But the decision is always down to your client device. And that is what we wanted to talk about here. And on the left-hand side, we've just put a bunch of different reasons as to why the client device may prefer one access point over another. And it also comes down to the client device decision for when they wants to roam away from one access point to another access point as well, and then which one it's going to associate to. So that's what we call the green diamond algorithm for getting associated to the network.
Okie doke. So we have discussed how we discover the potential radios to connect to, and then the decision-making process from the client's perspective when it comes to which AP to associate to. And now let's discuss a security bit, like a quick intro into security, because this is what happens next. And why do we care about how we configure the security stuff in our Wi-Fi network? But before we got there, I just wanted to highlight a few nice comments. First one, that Stu is looking very serious. He's probably learning something new tonight. And another comment about having some bacon on pizza, or beacon on a pizza. That might be the tipping point for Anders.
You know what we should have done is we should have put up a picture of a pizza with some pineapple on it, and that would have got everyone really fired up.
Yeah, no.
Should we have pineapple on pizza or not? I mean, let us know in the chat if that's okay with you or not. I don't know if there's anyone.
Let's not go there, man.
maybe we have some people from Italy on the webinar today who are now very, very offended and would have just hung up on us.
Well, I can see like some Canadian bacon comments, probably with maple syrup, right, Stu?
Well, yeah, that'll be okay. That's approved. Yeah, that's allowed. Yeah, I'll allow.
Okay, let's not digress. My fault. Sorry, guys. So Wi-Fi security. So we have a mission. We want to protect our data, because who wants to have the data breached? We want to protect our network from attacks, because who wants to have a network that doesn't work? And we want to protect our performance. And in order to do it, we have multiple different hows. How do we do that? How do we achieve that mission? So first of all, to protect our data, we want to use strong authentication and encryption. And for those of you who don't see a big of a difference between authentication and encryption, authentication is like a gateway to your network, okay? So you have to be authenticated to connect to the Wi-Fi network. And then after you are authenticated, you will have to encrypt your traffic, possibly, if you are using security method that requires encryption, that is. But the encryption is like a unique language between you and the access point, you as a client, and an access point that you will be using, so no one else can understand it without learning that language key first. So that's the authentication and encryption. Then, in order to protect your data, you want to locate and remove Wi-Fi devices in your wired network that broadcast Wi-Fi that is easy to access and can provide an easy access to your wired network. No one wants that, right? And then you want to protect your network from attacks, like a spooky, easy attacks. Attacking a network prior to WPA3 with no management frame protection turned on is as easy as getting to your environment and sending a deauthentication frame. And then all the devices, they will drop off their radios, okay? So that's simple. It's extremely easy. And we can protect our networks with PMF, MFP. We'll talk about it in a sec, with some caveats, okay? But it's a great idea to consider it, especially today. And then we want to protect our performance. And to protect our performance, we can design our SSIDs in a correct way. You might think, how does it matter how I design my SSIDs? What do you mean? SSID names, security on the SSIDs, everything will matter when it comes to performance. Bear with us. And you want to use encryption that doesn't slow your network down. What do I mean by slowing our network down? There are some different encryption flavors, and some of them, they are slowing your network down without you probably knowing about it, possibly. And then you want to be able to locate and remove RF interferers. So that's the devices that are wireless, not necessarily Wi-Fi, operating in the same space as your Wi-Fi devices that can be eating up the airtime that would have been used otherwise by your Wi-Fi clients. And we want to remove them, right? Because if they are competing for the airtime, that's less opportunities for our Wi-Fi clients to transmit. And now, some of you, or all of us, we have had these questions in our heads at some point in our Wi-Fi careers. And there are quite a few of those questions, like how do we achieve this house to achieve our missions? Like, should I use open, enhanced open, web, WPA, WPA2, WPA3, or should I use personal or enterprise? Should I stick to captive portals? Are they still cool to use? Okay. If you want to locate Wi-Fi devices that are providing easy access to your network, why do you have them in your network in the first place? How do you locate them and remove them from your network? If you enable PMF, protection of management frames, will your clients still be able to connect to your network? That's a very good question. And if you are designing your SSIDs, should you be using the same SSID name across all three bands, or should each band have a unique name for the SSID so you don't have cross-band roaming? Good question. Use encryption that doesn't slow your network down. So should you use TKIP or AES? Which one is the dodgy one? We will answer that question momentarily. And locate and remove RF interferers. How do you locate RF interferers? What tools do you use and how do you remove them from the network? We will try to answer all these questions in today's webinar.
Yeah, so let's have a look at some of those Wi-Fi security options that Mac was just talking about. And first of all, we have got the open Wi-Fi security option, which offers us absolutely no layer 2 authentication or encryption. So when would you typically be using open security is probably for guest access. So when you're creating a guest SSID, you would typically have the open option selected here, and in most scenarios, people would also use a captive portal. I can see a few comments in the chat as well about people saying, answering back to Max saying, were captive portals ever cool? Well, if you've worked in Wi-Fi for a little while and you've had to deal with working in the support or troubleshooting Wi-Fi networks, sometimes captive portals can cause us some issues, because let's say that someone associates to the wireless network, they get their IP address, they are able to associate, but they don't get presented with the captive portal where they can put in their first name, last name, date of birth, inside trouser leg, anything else that these captive portals are sometimes asking us to fill out, and then accept some terms and conditions, which then gives you access to the internet. But what happens when the device doesn't get prompted for that captive portal? The experience from the user side is just that the Wi-Fi doesn't work, but I mean, you've actually associated to the Wi-Fi and you've got an IP address, and now you're actually at those upper layers. And it's just because of the captive portal. So captive portals can cause us some issues with getting devices associated. So that's the open security that we wanted to discuss.
And you can also sniff out traffic to see who is already authenticated and steal their MAC address and keep on using the network without having to go through the captive portal. But don't tell anyone that I've told you.
And then introduced very early on was something that's called WEP. And basically this was the first kind of authentication we had, which is using shared key, but it wasn't very strong. So in fact, actually, it was very easily to crack and to be able to decrypt traffic. So we really recommend that you don't use WEP if you've got it turned on your network, and people can crack it in a matter of, it's probably seconds, minutes, hours at the absolute max, and then they're going to be able to see your encrypted data. So we highly recommend to not use WEP. Then the kind of like hot fix patch for WEP was what's called WPA or WPA1. And this introduced some different types of authentication now. So we can do something that's called personal, which I'm sure everyone is very familiar with, pre-shared key. So when you associate to a Wi-Fi network and you put in a code or a key to get connected, that's the personal pre-shared key. And then you have the enterprise option, which is 802.1x when you're doing authentication against some form of a radio server. the type of encryption that we use with WPA1 is something that's called TKIP. And TKIP, if you have that enabled on your network, this only enables 802.11a, b, and g data rate. So this means that the maximum data rate any of your devices associated to the SSID with using WPA1 is only going to be able to do a maximum data rate of 54 megabits per second. It also limits your devices to do one spatial stream. So if you have this enabled or on in your network, this could be something that is causing you some performance issues and is also not very secure. So again, we don't recommend that you use WPA1.
Yeah, thank you, Matt. And also WPA1 was designed to work on the same hardware, same devices, because it was the hotfix as the web was running on. So they couldn't really change the encryption to ensure compatibility with devices out in the market. And then we have a WPA2. So WPA2, it continues what WPA1 has started. So we still have a PSK and .1x flavors, personal and enterprise. Personal is password-based and enterprise is a radius-based authentication. But what has changed is the encryption. So we can still use TKIP based on the RC4, so same as encryption as in WPA, but we don't want to for reasons that Matthew has mentioned. It slows down your network quite dramatically, so don't use it. And it's also crackable, so don't use it. What you want to stick to is CCNP AES encryption that is now, it fixes all the shortcomings of TKIP pretty much. So it's still considered secure. It doesn't slow your network down, and it's the one to go for when you're using WPA2. So that's WPA2. And then we have something called the Enhanced Open, quite recently introduced. This tries to address the shortcomings of the open type of security, which is pretty much no security. So with open, you have no authentication and you have no encryption on layer 2. Okay, the captive portals, they are at what layer? They are at layer 3, right? So your wireless transmission, which sits in layer 1 and layer 2, it's not encrypted, it's clear text. And we want to change that, right? To give people more privacy so their data cannot be eavesdropped. And Enhanced Open, it achieves just that. So you still have no authentication, so you don't have to tell the network who you are. You go through the gateway like it's your network, but then in the background, you have Diffie-Hellman involved in, well, Diffie-Hellman keys exchange algorithm done by these two guys introduced to the market to create authentication, well, encryption keys that encrypt your traffic in a way where it's encrypted and secure. But the user experience is the same. Enhanced Open is as simple as open from user's perspective. You click on the network, you connect, you're connected, but your traffic is now encrypted, so it's amazing. Then you have WPA3. So WPA3, it's a little bit of a funny thing today because WPA3, it changes the default behavior of PSK. Actually, we don't have PSK anymore. We still have WPA personal in this scenario is WPA3 personal, but we are now using simultaneous authentication of equals. So in WPA2, PSK, so PSK is a 256-bit key that is used to not only authenticate, but also to encrypt the traffic. And if you know the PSK, if you know the password that is used to create the PSK, you can decrypt a traffic that was generated by your device, your colleague's device, colleague of your colleague, for as long as they are using the same pre-shared key, you can decrypt it very easily. If you have an employee coming back to your office a few years later, if you haven't changed your PSK, they will still be able to decrypt that data. And it can lead to security vulnerabilities, right? So with SAE, you still have a password. So from user's perspective, nothing changes. They still connect to the network, put the password in. It's easy peasy, lemon squeezy, but now the password is used for authentication, but not for encryption, okay? Encryption is Diffie-Hellman again, and you cannot decrypt the traffic with just a password anymore. It's not as simple as it used to be with WPA2. We still have AES flavor of encryption, and the funny stuff now is that WPA3 is mandatory in 6 gigahertz. So if you are using Wi-Fi 6E and you have some 6 gigahertz clients, they will support WPA3. They have to, right? They are required to. But then if you have the same, let's say, SSID name on 5 gigahertz, 5 gigahertz devices that don't support 6 gigs, they will not necessarily support WPA3, right? And that might lead to compatibility issues. Cool. And also WPA3, it introduces a mandatory support for the PMF, Protected Management Frames, also by some people called MFP, Management Frame Protection, which is actually the name that Cisco has introduced as a proprietary thing before PMF was an official amendment. Okay, so management frame protection, very important thing to protect your network from easy attacks like deauthentication frames. It encrypts most of the management frames, not all of them, some action frames, making sure that you cannot attack them that easily. And that's WPA3. Cool. But without further ado, let's take a look very quickly at a Wireshark, where I will show you.
Yeah, I'm really excited to see this, because now Mac has been talking about it. Let's actually see it in action, Mac.
Okay, doc. Let's see the Wireshark. You should see it on the screen now. So before we talk about security here, let's go through the association process first. It might be the first time some of you see that, so it's quite cool. So here we have an Apple phone broadcasting a probe request on channel 100, asking, hello, anyone out there on that channel? I want to associate on that channel. And then we have a missed AP coming back to our Apple device with probe response. It's no longer a broadcast saying, hi, I'm an access point available on the channel for you, my friend. You can connect to me if you want to. So discovery is now done. Now, assuming that there have been more responses on the same channel, the client might have a tough choice to make. Which radio, which BSSID do I connect to? It has decided to connect to that particular missed IP on channel 100. So it sends authentication request, which is open system authentication, always successful. It gets the authentication response from missed access points in response to the authentication request. Then we go through the association request, and it's also successful with association response being sent from the access point. And now the client is associated to the access point. They talked about what they can do. They agreed that they can work together. Client has associated to the access point, and now the association in wireless is the equivalent to link light in wired, like the blink, 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 you know, green little beautiful light on your switch. And if it was just the open network, that would have been it, okay? That would be everything, and your gateway is open. You can pass data through your access point. But this is the PSK-based network, so you will go through four-way handshake, where your client and the access point will derive keys from the password, from the passphrase that you put in, and have two different types of keys to encrypt unicast with PTK, and then multicast and broadcast with GTK. Getting a little bit deep there, but you will have these two keys to encrypt traffic at the end of four-way handshake here. And now, we are now allowed to start passing data through the access point. So what would we expect? We are done with layer 2, we are connected to Wi-Fi, associate to Wi-Fi, authentication is done, encryption is done, we have the keys to encrypt our traffic. So I would expect to see something like, I don't know, maybe DHCP or something like that. But what I see instead is some QoS data, QoS data. So this seems to me like it's encrypted. I cannot read that. I don't know what it is. But wait for it. If you know the password that is used to generate the PSK that is then used to authenticate and that is then used to derive keys, PTK and GTK in your network, you can decrypt that traffic. So let's take a look at how you do exactly that. So you go to your preferences, and then in protocols, you use you look for a Wi-Fi. What is Wi-Fi? Who has created Wi-Fi? So Wi-Fi is a name made by Wireless LAN Alliance, Wi-Fi Alliance, but it was created by IEEE, nerdy, amazing guys. And the standard is 8.11, okay? So I look for that. I have decryption keys, edit, and then I want to add my key. So where do I add it? Is it web? No. Is it WPA password? Maybe. Is it WP2 PSK? No, because PSK would be 256 bits key, which we don't know. So I will stick to WPA password, and I should have it here. That's a very secret password. I will add that. And now before I hit OK button, let's take a look at what happens to all this quotes data stuff. I hit OK, and whoop, it all has changed. I can now see the HCP request, the HCP acknowledgement. So my data is clearly decrypted now. And this is how easy it is to decrypt any WPA2 PSK encrypted traffic if you know the key, the human readable password key. Okay, that's quite easy. And just for your benefit, guys, if you want to crack enterprise, it's also possible, but under very specific circumstances. It's very secure because in order to crack it, you need to have a wireless capture at the time of authentication. You need to have a wired capture at the time of authentication. You need to have access to the wired network, right? And also you need to know the radius key. So if you have all these 4 things, then you can decrypt .1x as well. But you won't have these 4 things, so it's still considered extremely secure. Okie doke, so that is everything when it comes to this quick demo. I will stop sharing now. And Matthew, my love, it's your turn.
Thank you, Mac. That was a really good demo. Really nice to see that there. And a lot of questions coming in about what you had kind of set up there. And it's that Wireshark profile that you had there was the ECSC wireless that we set up in the new ECSC troubleshooting class, which we'll talk about in a few slides time. But what I wanted to talk to you about is an example of how we think that you possibly could be designing your SSIDs with all 3 frequency bands in mind. And just to call out a caveat here is that this is not one size fits all. You do have different requirements for your different environments. So this is just our suggestion here. So let's start off with the 2.4 gigahertz frequency band. And if we were to be deploying a network today, this is how we would probably be setting it up. So the 2.4 gigahertz, we would probably be only using this for IoT connectivity. So connecting devices, I don't know, we could ask Mac to list his 80 different IoT devices that he's got associated to his home Wi-Fi environment, from, I don't know, like toasters. What else have you got, Mac? That you got Hoovers?
I have five Robo Hoovers, 1 Robo Mower, cameras, locks, everything.
Exactly. Oh, look, so if you ever want to get into Mac's house, just jam that 2.4 and then you can get easy access by the sounds of things. So anyway, 2.4 gigahertz, we would use this for our IoT connectivity for the those devices. And how we would be configuring them, what security, we're probably going to be using WPA2 personal pre-shared key, because these devices, they're not necessarily that sophisticated and can support the things like radius authentication, and it's just going to be simple on 2.4 gigahertz pre-shared key. And always, what do we do in 2.4 gigahertz? We stick to 20 megahertz wide channels. Okay, nice and easy, 2.4 done. So how about 5 gigahertz then? Well, let's start off with guest. How are we going to have access to our Wi-Fi network from guests when they come into our environment? We would set up the guest SSID to be 5 gigahertz only. And what we would use here, again, it would be WPA2 personal, so pre-shared key. One thing that we would also try and implement, if our vendor supports it, maybe it would require some third-party integration as well, something that we refer to as MPSK, so multiple pre-shared key. Sometimes different vendors call it IPSK, identity pre-shared key. But what we can do here is that when you have a guest turn up, you can give each individual guest their own pre-shared key to get authenticated to the network, which is a way more secure method because it's not just one key being shared around with everyone. And just like what Mac showed you before, when you know that key, you can just see everyone's data. So that is probably what we would do for guests right now. And on 5 gigahertz, we would stick to 20 megahertz wide, because at the moment in most environments, the contention on 5 gigahertz is still quite high, and the payoff from having less channel contention from 20 megahertz wide channels versus the wider channels that give you the faster data rates and some faster throughputs, it's better to have cleaner quality air rather than those higher data rates and throughput. Easy peasy, lemon squeezy, IoT and guest so far. But then how are we going to configure our corporate environment now, bearing in mind that more and more 6 gigahertz devices are starting to come onto the market and we want them to be able to connect to our network? Well, we would probably split our SSIDs now between 5 gigahertz and 6 gigahertz. We're going to have one corporate SSID focused purely on 5 gigahertz, and then one corporate SSID on 6 gigahertz. And the two main reasons why we're going to do that is because remember when we were talking about earlier, that green diamond algorithm, our device's own internal decision-making system for what access point they're going to associate to which radio, and so on and so forth. Well, if you have the same SSID broadcasted across multiple different frequency bands, you do not have guaranteed control on which frequency band your client device is going to associate to. So when you've got it broadcasted across multiple frequency bands, sometimes your device might associate on 2.4 gigahertz, then it might roam to 5 gigahertz and then roam back to 2.4 gigahertz. And in most scenarios, we don't really want that to happen. We just want to keep them connected on that single band. So for 5 gigahertz corporate SSID, we would make that 5 gigahertz only. We would leverage WPA2 enterprise here, 802.1x, authentication with a radio server, and again, stick to 20 megahertz wide channels. 6 gigahertz, well, this is going to force us now to use WPA3 because WPA3 is mandatory in 6 gigahertz. So here comes that second reason why we would have single band SSIDs, because if you configure just the corporate SSID to be broadcasted across 5 and 6 gigahertz, what about if you turn on WPA3, you think, okay, I'm going to enable that on my corporate SSID, because 6 gigahertz is mandatory. So now it's just enabled across 6 gigahertz and 5 gigahertz. But maybe you don't have complete control of every single device that's coming into your environment. Perhaps some of your devices, they don't support WPA3 yet on 5 gigahertz, but it's enabled. Now, this could be a potential compatibility issue, and they may not be able to get associated. Now, some vendors are implementing what's called a transition mode. So if you've got 6 gigahertz access points with the WPA3 enabled, on the other SSID on 5 gigahertz, it could be in transition mode. So if the WPA3, if a device supports it, it can connect. And if it doesn't, it would use WPA2. But again, not all vendors are implementing that, and it could be causing some connectivity issues. So to keep it as simple and compatible, we would split out those SSIDs, just have your 6 gigahertz devices connect on 6 gigahertz, just have your 5 gigahertz devices connect on 5, and you're going to have a better experience, we believe. And how we would configure 6 gigahertz SSIDs right now in the US, because you've got all that additional frequency space to use probably 80 megahertz wide channels and leveraging those PSCs. And then in the EU and the UK, we would stick to 20 or 40 megahertz wide and probably heavily rely on things like reduced neighbor report that we spoke about earlier.
That was quite a lot of juicy information, Matthew.
Well,
I think you guys need to work on expanding the spectrum over there. That just sounds like the logical solution, right?
Yeah. I mean,
single band makes a grant.
Right, get on that. You guys are over there. Get on that.
Yeah, and guys, by the way, this is not like one size fits all. Maybe in your environment, you want to have guests on 6 gigahertz, right? It's like, this is just like a typical carpeted office space that we've seen on the previous slide that in most cases will be a good fit to avoid issues with roaming and compatibility between your clients, right? But it's not the same for everyone. Coolio. So we have established that we want to stick to a single band with our SSIDs if we can. If you want to be grant. If not, then you can have the same SSID across all 3 bands. Coolio. So what happens if you have 5 gigahertz SSID with WPA3 configured on it? Is it possible? It is possible. What is the likelihood of 5 gigahertz clients supporting WPA3? Do you have any? Of course you do, but not all of them. Most of them actually will not support WPA3. There will be 5 gigahertz and WPA2. So if you are troubleshooting a network, you can use our amazing wireless LAN scanner, Ekahau analyzer, to see what security is configured on your 2.4, 5, and 6 gigahertz network if you have Sidekick 2 connected to the device of your choice, right? So let's move to the next slide. And this is like a very secret slide, guys, so we cannot dwell on this slide for too long because it's a brand new thing and our product team will kill us all if they see that we are talking about stuff that has not been released yet. What is going to happen there? But whatever. Let's take a look at the security column and you can see that we have 6 gigahertz network. So a Sidekick 2 is working on analyzer and it's a WPA3 network. If I had WPA3 on 5 gigahertz bands and switched to 5 gigahertz tab, I would be able to see that there as well. But what do I see there? Utilization in percent and BSS utilization. Oh, some fields that we have not seen before, or at least one of those fields. Actually, I can see 2 on the screen, but we have more. We have like 10 or 12 fields that we haven't seen before. So, ladies and gentlemen, the new tool is coming, but you haven't heard it from us.
Yeah, so no one tell the product team that we showed this today. So otherwise you might get us in trouble. But we're so excited about it. We wanted to give you a sneak preview, and we felt it was very topical when talking about the security methods, especially with 6 gigahertz. And if you do tell anyone, tell them it was Mac, not me. So we can just all blame Mac.
Oh, actually, we can say it was you because he's a director and he has
right.
force.
Yeah, just, you know what? It's okay. I'll take it. Throw the tomatoes my way.
The tomatoes and the pineapples all coming your way, Stu.
Right.
And ham with the pineapple.
Yeah, so how do we achieve great Wi-Fi? And we have got our 3 great steps to great Wi-Fi. So you step 1, starting with a great design. Then step 2, make sure you validate your great design with the super accurate measurements results of the Psychic 2. But what we really want to focus on for this part of the webinar is talking about step 3, is how do we maintain and keep our Wi-Fi networks high performing? And the way we're going to be able to do that is with doing regular health check surveys, periodic surveys, making sure we are checking our environment, because you'll be amazed about how much changes in the environment, even on a day-to-day basis. Different people bringing in devices that they thought were harmless and not going to cause any issues in your environment. People reconfiguring different spaces, so maybe taking down some walls, maybe creating some more areas for some event spaces, so you've got a high density area of devices and users as what you had planned in your original design. What about if you did a design for a warehouse or manufacturing and you've had different stock levels, different racking layouts changed, or they've added some additional racks to the environment? Some of these things, they happen all the time. Another big thing that we see when we talk about carpeted office spaces, if you have a multi-tenanted building and you do a survey validation of your stakeholder on, say, floor 3, then you have different people move in on floor 4 or floor 2, and they bring in their own Wi-Fi networks, and now all of a sudden they can be heard on your floor 3, and they're using up all of the Uni 1 band or 5 gigahertz, and maybe you need to make some changes to your environment. So it's really a great way to keep your finger on the pulse of your Wi-Fi network and make sure that all of your users have great Wi-Fi and it stays high performing.
And what do we have here? Yeah, so guys, if you like the topics that we are discussing now, but you would like to dive a little bit deeper, we have a brand new ECSE troubleshoot course available now. And we talk about security, we talk about roaming, we talk about the protocol, we talk about how you can leverage Ekahau tools to troubleshoot your networks extremely fast and be a hero very fast. So this is, I think, now one of my favorite courses I've done. And I'm not exaggerating, I'm not biased because I'm Mr. Mac Ekahau now, but it's an amazing course and I hope that you will find it amazing as well.
Yeah, so if you want to find out more, you can simply head to that URL, or you can scan the QR code and it's going to take you over to our website where you can find out all of our upcoming schedule for the ECSE troubleshooting course. Mac, talk to us about some of these common RF interferers then.
Yes, sir. So we have common interferers. So guys, what you can find in your environment, now you can think and feel that interferers, they are mostly in 2.4 gigahertz band, and that is true. But as you will see in a second, you will also have this interferers like crawling into 5 gigahertz band and soon 6 gigahertz band. We already have like incumbents in 6 gigahertz that can really make our Wi-Fi not work too great on particular channels. And we have to do these performance checks with the health check surveys to find the interferers, to remove them from our network, to protect our Wi-Fi. So the most popular interferers in your environments, they might be other Wi-Fi, okay, because there is tons of other Wi-Fi all around. But also, it's not unusual to see a microwave oven or to see a drone running through your office, right? Drew, is that what happens, Stu? Is that what happens in your office on your spaceship?
Sometimes, yeah. Sometimes it gets a little out of hand and just kind of just runs around everywhere.
You have BLE and Bluetooth on 2.4 space. If it's just one device or 5 of them, they won't interfere with your Wi-Fi. But if you have more of them, they might. And without doing health checks, without checking what's happening in the spectrum, without using your spectrum analyzer to locate those devices, to find out what is happening in your network, you wouldn't even know about them.
Yeah, so what we want to show you is actually what some RF interferers look like when you have picked them up on doing your survey. So what we have got here is a couple of devices that's causing us some interference on 2.4 gigahertz. So not only can, when you do your validation survey with Ekahau or your health check survey with Ekahau, we can locate the access points in the environment and place them on the floor map for you. We can also place interferers on the floor plan too. So what you can see here is that we've actually got a couple of 2.4 gigahertz cameras, and the channel that these are mainly operating on is around channel 1. And the visualization that we're looking at right now is the interferers visualization. So it's showing us just how much of the area of impact these devices are having. And then on the right hand side, we're seeing the spectrum, and we can see on channel 1 that that signature has been detected, and we've detected it as a video camera on channel 1. But what else can we see here is that, you know, if you have some of these access points around here trying to use some of those channels, it might not work too well. But why would it not work too well? That's because typically when you have got this layer 1 RF interference and these types of devices in your environment, it's because they are typically transmitting most of the time, or if not all of the time. So what we're looking at now is the channel utilization from the spectrum analyzer perspective. So what we see here is around those around channel 1, so channel 1, 2, 3, the channel utilization is 94%. So that effectively means that these devices are constantly transmitting. So if you had some devices here, some access points trying to use channel 1, they basically would always detect that the medium is busy, there's energy there, and they will never try and even transmit your beacons. You can't get associated, and it's going to cause us some connectivity problems. So not only do these devices make your Wi-Fi performance worse, again, if you've got these in your environment, they could be a security vulnerability, and we will want to remove them. And you're thinking, hold on a second, you just told us the 2.4 gigahertz is the garbage band. Why do I care about, you know, these devices on 2.4 gigahertz? And it's not just 2.4 gigahertz. So Mac, tell us about these ones on 5.
Exactly. So what you can see here now is we have a camera, like it's in the middle of a server room, okay, that camera, but it's not unusual to see the cameras at the entrance to the rented office space outside of the lift area, where you will have some wireless but non-Wi-Fi cameras operating on either 2.4 or 5, and they will be smashing the spectrum with like 100% or close to 100% of spectrum utilization of density in percent, where it gives your Wi-Fi devices pretty much zero room for transmitting their data, because Wi-Fi device will always listen before it talks, and it will listen, anyone out there on my channel? There is a camera. I will back off. Try again. Anyone out there? There is a camera, because it smashes the spectrum 100% of a time. Let's move to the next slide, and let's take a look at the channel utilization on channels 161, 165, and 153. That is very close to 100%, meaning that Wi-Fi on those channels will not work in this particular geographical area around the room where the camera is in. You will have to stick to different channels. If you are just smashing 3 channels and have 1 camera, that might not be a problem, because you can choose different channels. But if you had 10 of those cameras, okay, they might be taking entire 5 gigahertz spectrum out across entire floor or entire building. So we have to be very, very careful, okay? And all it takes for your Wi-Fi devices to defer is around next 62 dBm. If they hear the camera or any other interfere with that or higher, they will not be able to transmit at all. They will always defer, okay? And then another thing, if you have a duty cycle that is smashing the spectrum 100% of the time, your Wi-Fi is dead. But what happens if you have an interferer that is not as strong, but it's still there? It's quite apparent. What is the channel utilization that you want to be below in order to use a voice, for example, or video? And the quick answer to it is, of course, it doesn't have to be 100% true, but it will be close to it. If you have 20%-ish of sustained channel utilization, then you will be able to have seamless voice experience in your network. 30%, and you will be able to have a video. If you have more than that, then you will see some jitter. You will see tons of retransmissions. You will see your Wi-Fi devices differing. They will not be able to access the medium when they want to. And since voice is being sent every 20 milliseconds, if you lose one packet, second packet, third packet, the person on the other side will start hearing cracks in your transmission. And if someone turns on the camera on the channel that you're on and it smashes 100% of a channel, then your voice conversation is over.
Yeah, so the real benefit of doing a health check survey here is that let's say that you'd perform this health check survey, you would be able to identify these devices operating on the higher channels of 5 gigahertz. So then you could go back to the stakeholder and say, hey, it would be very beneficial if you could maybe reconfigure these devices, remove them. Can you hardwire them in so they're not operating on our Wi-Fi frequency? And if the answer to that is simply no, then what that could mean is that you would then go back and then maybe update your design to be able to not use those channels, because perhaps in the original design you were going to use those upper 5 gigahertz channels, but now you can see that in this area you'd probably want to avoid them. So one of the good benefits of doing health check surveys, identifying these devices. So that was identifying these kind of devices at layer 1. Well, how about identifying interfering devices at layer 2? And what are these potential kinds of devices? So what we've got here is a floor plan from a validation survey, health check survey that we've got. The white icons are the customer's AP icons, and then the red icon is the coverage we are seeing from that device only. So we're seeing all of that green and that gray coverage. So that's how much of the floor plan this device can be heard. So what we can see is it's covering pretty much most of the floor plan. Most of the other access points are going to be able to hear it. So what actually is this device? And it's a printer that has its Wi-Fi enabled, and it's, you know, causing a lot of coverage area, which means the other devices in this area, if they're using 2.4 gigahertz on the channel that it was using, is going to create channel contention. But when we showed this back to the stakeholder, they said that they didn't even have any idea that the Wi-Fi was enabled on this device because it has got a LAN cable connected to it. And the way that users print their documents, they don't disconnect from the corporate SSID and then go and associate to the direct -Y0-studio X30 SSID and then print their documents. They just print it through the corporate network that they're associated to on the Wi-Fi. So the printer doesn't need to have the Wi-Fi enabled. That's not their process to, you know, print their documents. The other thing as well is that if this device is using WPA2 pre-shared key, if this key has not been changed or rotated and there's a bad actor nearby that can hear it, you can see how far this, you know, device is able to be heard. How about it could be going outside onto other floors, and if you could know that pre-shared key, you could get access to that device, and then you could potentially have access to the corporate network. So again, it could be a security vulnerability, disable it, and then it will also improve your performance on your 2.4 gigahertz network. But you may be thinking, you know, a printer with its Wi-Fi enabled in an office environment, how often does that really happen? And well, we've got another example right here, and the orange icons now are the stakeholders' access points, and all of the red icons are actually printers with their Wi-Fi enabled. And we're looking at the coverage coming from those devices. So on 2.4 gigahertz, you can see that just these 4 printers alone are covering the whole floor plan now. And 3 out of those 4 printers are using channel 1. And you might be looking at this and think, did this customer of yours deploy a single channel architecture? Because all of their access points seem to be using channel 1 as well, but no, they didn't. It was just a decision that the radio resource manager had made, was to use channel 1. So all of the customers' access points using channel 1, plus all of these, you know, these printers as well using channel 1 with their Wi-Fi enabled, was creating a lot of channel interference. So 14 of the same radios all sharing the same channel. The more channel contention you have, the less capacity you have on the channel, and the less amount of devices are going to win the opportunity to transmit their data. So it's going to be a performance killer. But again, in this scenario as well, the stakeholders, they had no idea that these printers had their Wi-Fi enabled. They've never changed the default password for the printer, and it's just a weak method of access to get onto the corporate network. So they, as soon as we showed them this, they found the printers, they disabled the Wi-Fi, and it removed some of the channel contention, and it also removed that security vulnerability. But again,
Yeah, so it's easy with printers, Matt, isn't it? Because printers, they are typically connected to a wired network anyway. So you disable Wi-Fi, everyone is happy. But move to the next slide.
yeah.
And
What I was just going to say is that people are thinking, you know, you've just told us the 2.4 gigahertz, the garbage band. We don't care about that. It's IoT only, whatever. But now, what about this one on 5 gigahertz Mac?
Yeah, exactly. And look, these devices, like all of them in red, they are kind of media sharing devices in meeting rooms, boardrooms, whatever. And these are being heavily used by the users presenting in those meeting rooms, right? So you have a user coming into a meeting room that has a click share device or whatever it's called on channel 36 or 40 megahertz. So it takes channel 36 and 40, and users, they will connect to that device to then share their stuff on the screen, on a big screen. And sharing stuff over Wi-Fi is, especially if it's like a stuff that moves around your screen quite a lot, it can be quite heavy. It can contribute to quite a lot of channel utilization. And look at the channels that those devices are using. They're not only covering entire floor, but they are killing Uni1 band completely. And by Uni1 band on 5 gigs, I mean channels 36, 40, 44, and 48. So these are the golden channels to use when you have voice, for example, in your network. And why do we want to prefer Uni1 for voice when compared to other available bands? Because this is the non-DFS band. We have more channels available, yes, but on non-DFS channels, we can probe. So our clients, they can be on a voice call and they can go quickly off channel and then ask on the next channel, off channel, anyone out there looking for a better candidate to roam to, and then they will have probe response coming back to them straight away without having to wait for beacons. Whereas if you have non-DFS channels, if you have DFS channels, sorry, so not Uni1, you cannot do that. You have to wait for beacons, so that's slow. And since we have click-share devices across entire floor, taking entire Uni1 band, we will have to stick to DFS channels, which might slow roaming down and kill the fun when it comes to voice. So we'll have to be careful with that. And also, this is on 5 gigahertz now. It's only a matter of time until those devices, they sneak into 6 gigahertz band as well. So everything that we have discussed about 2.4 and 5, how to locate those devices, what does it mean for your network, it's 100% translatable to 6 gigahertz as well.
So just to summarize then, the benefit of doing these health check surveys is not only can you identify where these devices are, when you can show them to your stakeholder, you can fix some of these security vulnerabilities and you can massively improve the performance of the Wi-Fi network. It's just win-win-win scenario situation from doing these regular health check surveys. It's going to improve the performance of the Wi-Fi network and it's going to help keep your Wi-Fi networks as secure as possible, which is what we want to achieve. So that is the end of our presentation of the security webinar, and we have got some time to take some questions, so we could answer a few Q&As right now. So over to Mr. Force.
Thanks. I think one of the key things, and great webinar, and I think that one of the key things that that we're seeing in the webinar chat and also in the Q&A is, what are we going to do for those, SSIDs that we, in the past we had a number of SSIDs per band, right? We want to make sure that we didn't have too many SSIDs, I say per band. We'd have too many SSIDs on a specific access point. Are we going to see that same thing on 6 gigahertz as well? That we're going to have to lower our overhead?
So that's a really, really good question. And one of the things I know is quite a while ago now that we had up on the slides about the 6 gigahertz discovery was this this other new thing that's called the multiple BSS. I can't remember if that's the name, but basically what it does is that the reason why, first of all, the reason why you didn't want to have too many SSIDs broadcasted on the same radio or frequency of an access point is because the more SSIDs you have means it's the more management frames that are getting sent out. And why is that a problem? Is because all management frames are sent out at the minimum lowest configured rate. So it basically can create more utilization of your network even without any devices being associated. So the more amount of SSIDs, the more beacon frames, the more management frames going out at that lower rate. Well, in 6 gigahertz, there's this new thing where basically when you have got multiple SSIDs configured on the 6 gigahertz radio, it combines all of them into a single frame. So rather than seeing, let's say you had 10 SSIDs before on 5 gigahertz, you'd be seeing 10 beacons 10 times per second with the 10 different SSIDs. Whereas now on 6 gigahertz, what you'll have is just a single beacon containing all of the 10 SSIDs. We still probably don't recommend that you need 10. I'm just using that as an example. But yeah, so it's not something we have to think about quite so much. But again, we probably still a good amount of
early days,
SSIDs.
right? We're in
Yeah,
a bit of early days, and I see that we're going to definitely kind of be growing it and learning a lot more every day. But I think customers like to kind of understand to reduce the complexity, right? We can all agree we want to reduce complexity of Wi-Fi as much as we can and make them efficient as possible and use the tool sets to do that, right?
Absolutely.
Absolutely, man. It's like when we started like learning about networks, our labs, they were massive. And then every time something was breaking, we were removing it from the network to the point where we have nothing. Now I have just like a switch and 2 access points. That's all I have. Beautiful days. Everything works.
Right? Got to be able to operate all those extra little gadgets in the house.
They are enough, man. It's like I have 80 plus clients. They are working spotlessly. Okay, do we have any more questions? One more question before we wrap up?
I think we get it covered here. It definitely folks are really kind of, trying to learn more about understanding, bridging the gap between, 5 and 6 gigahertz, between WPA2 and WPA3. Folks are saying, well, can I not have WPA2 on 6 gigahertz, right? Because I'm trying to transition. And I think
yes, so you cannot have WPA2 on 6
right?
gigahertz. 6 gigahertz is 6E only fresh band, no support for legacy devices, no support for legacy PHYs. It's just AX in 6 gigahertz, and that means that we can use just WPA3 on that band, and WPA3 on top of that enforces management frame protection or protection of management frames. So that's double combo bonus for us that we have to be mindful of. And some vendors, they do transition mode where you can use both WPA2 and WPA3. And some vendors, they do it better than the others. There is one particular vendor that does it best and it works. I haven't tested many other vendors, to be honest. But yes, you have transition modes, it works, and WPA3 is a thing, and it will be the only thing on 6 gigs.
Okay, great. Well, a big thank you to everybody that has joined us on the webinar today. We hope you enjoyed our spooky theme for security in 6 gigahertz. And in general, I'm sure everyone is loving Stu's outfit. Maybe we should make him dress up for every single webinar. What do we think?
Let's do it.
All right.
Okay. Yeah. Well, thank you very much, everybody, for joining us today, and Mac and Stu, plus the rest of the amazing Ekahau marketing team. We will look forward to seeing you all on the next webinar in a few weeks' time. So, yes, maybe
right.
Stu can do a special Star Wars.
My ship now. I'll see you later.
See you later. You have a nice flight.
That's right.
Okay.
Ciao, guys.
Bye.